Sweet. We're a minute early, but I want to get a couple of housekeeping things out of the way. If you have not been scanned in and received a raffle ticket, see Alyssa, who is making her way right there with her hand up. Yes. There will be a raffle at the end of this, and I think we have, it's an echo spot, but you must be present to win, so stick around, please. And I'm going to kick off my automation here real quick. Let's not Terraform plan out tf.plan. I'm going to kick this off, and everyone can remember my super secret shared key. And we'll get to this in a later because I want to talk holistically about the ENCC exam from a cloud VPN and native capabilities. But I also want to show some things that we can do to make our troubleshooting a little bit easier because, like I said, I did come from a developer world. I love Terraform, and so these things will make it a lot quicker, assuming my internet works. And now we do the Terraform plan, apply, and that'll take about 30 minutes to build. So hopefully my timing is correct, and we can go ahead and get started. And I'm probably going to need to swap displays. Nope. All right, it worked. All right. Thank you for joining me. This is the first session in the Cisco Live Theater for Cisco Live APJC 2023. My name is Quinn Snyder. I'm a technical advocate with Cisco Learning and Certifications, and I assume that you're all here because you want to learn about Cloud VPN with our new ENCC certifications. Before I get started, real quick, show of hands, how many have heard of the ENCC certification at all? That's a shockingly low number of hands. So ENCC is our new cloud connectivity concentration for the enterprise networking specializations. So it's all about cloud connectivity. How do we get our on-premises resources into the cloud and share things back and forth? So that's a combination of standard IPSec tunnels, SD-WAN overlays, troubleshooting, design, management, all that good stuff that comes with all of the major cloud providers, AWS, Azure, and GCP. So today, I'm going to talk a little bit about how we can go from ClickOps to automation using Azure as our test bed to show and showcase the ENCC exam. However, before we get started, I would like to acknowledge that we're meeting on the lands of the custodial people in one of the oldest civilizations of in the world. And I would like to pay my respects to the elders past and present and recognize and pay my respects to the Aboriginal and Torres Strait Islander peoples here today and ongoing connection to land, sea, and community. So, our agenda for today, we're going to talk about the agenda, we're going to talk about the exam topics, we're going to talk cloud connectivity. Then I'm going to show some demos that are pre-canned that I made earlier around how our mouse goes clicky-clicky to build a VPN within Azure. What you saw a little bit beforehand was automating that, and I'll go through some of the code that I used to automate that whole process and how we can use the automation to make it much easier for some of the troubleshooting aspects that I'll talk about later. And then we'll wrap it up, and don't worry, at the end of this, I will have a QR code where when I catch a free minute, probably this afternoon, I will upload a PDF of the presentation, the sample Terraform code, a sample template of the config for my router, and a bunch of other stuff. So, looking at the exam topics for ENCC, there's two big pieces that I'm going to talk about today that are covered there. One is the IPSec cloud connectivity. How do we build IPSec VPN tunnels from our on-premises routers to our cloud providers using their native cloud constructs? So part of that is knowing how we build things like VNets or VPCs, how we assign virtual gateways, how we build local gateway constructs, and assigning those things with a connection to our on-premise resources so we can make sure that we have that VPN connectivity. The other piece of it is the management piece, and this is another kind of an underlooked piece. When we talk about ClickOps, how many have used a cloud portal before with the mouse driving back and forth? Click, 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 click. If you're talking about doing things very often, if we're talking how do we change IPSec policies or tear something down and come back to it later, that can be a lot of mouse clicks, and it's a lot of time to wait for that to build, and we have to be at our computer all the time to make sure that we can click and next window and next and wait for it to build. So when we talk about diagnosing IPSec connectivity or diagnose routing issues on iOS 6E routers, we need something that we can break really quickly, make a change, and not have to babysit the process as we're going back and forth. So we're going to use the automation that I've built to show how we can tie some of our developer connect tools with that management piece so we can do rapid troubleshooting back and forth. Now, part of the cloud is about terminology. So I'm covering Azure today. The same things apply whether we're doing AWS or GCP. They just call things differently. When we build a connection in the cloud, we have to make sure we have a virtual network. That's just our instantiation of our network entity, our LAN in the cloud. In that, we can host compute resources, we can host Kubernetes resources, we can host a variety of different things, but it all lives inside that virtual network where we have subnets and routes and things like that moving back and forth. For us to connect our local networks to the cloud over an IPSec tunnel, which is different than if we're doing something like a direct connect or an express route peering, which is shared infrastructure from a provider directly into the cloud network rather than over a VPN, we need to have a virtual network gateway. That defines kind of like our VPN concentrator of old in the cloud. Additionally, because we have that connection, we need to tell the cloud where to look for that local resource. That's our local network gateway, and every cloud has one. Whether it's called a local network gateway or not, depends on the cloud, but that allows us to bridge these two pieces together, our virtual network and our local network. We have to have some kind of entity that the cloud knows about. We're not just going to accept a connection from everybody. And then finally, we have this connection piece that ties all of those different VPN parameters. So we're doing IPv1, IPv2, what's our security policy, what's our ISACET policy, what's our IPSec policy, all those different pieces that build a VPN are defined in that connection. Now, I will say this, depending on how we want to exchange routing, there may be some additional parameters that come in that connection that may seem redundant. One of the ones that I'll call it in Azure, if we enable BGP in our virtual network gateway, but don't enable BGP in the connection, we won't pass BGP packets back and forth. Even though we've declared it, we have to also declare it in the connection. So there are little idiosyncrasies with cloud that say what define how we need to configure or build those things. But at the end of the day, this is what we're building inside of Azure. Now, if you would like to follow along, there's a whole series of tutorials that we have put out with learning and certifications on building cloud VPNs. So this tutorial here will take you right to the Azure VPN tutorial. There's also one for AWS and one for GCP that I've built that covers similar concepts. In addition to that, how many folks have a Cisco U account? Cisco U accounts, if you are interested in one, to access the tutorial, there's a free tier, which you can get access to all these tutorials. There's also some QR codes at the front there. In addition to that, if you're interested in learning more about the ENCC certification and a feel for what's available inside of Cisco U, the first section of the ENCC learning path is available for free today when you create an account within Cisco U. So, all of that's available free as in beer, so not the freedom kind, but the actual, you can get that for free and enjoy it. So the tutorial, if you want to follow along after the fact, and like I said, I'll have this PDF of the presentation uploaded to my GitHub, and there will be a link to that as well. But that link will take you to the tutorial. But our steps for building this Azure VPN, we create our VNet, which includes our Snyder block, as well as the subnets that we'll be using to create that VPN. And again, this is where it's different. Just because we cover one cloud does not mean that all the clouds are the same. In Azure, I can do a lot of things automated. There's only a few steps to create that. There's probably double the steps in AWS and maybe 50% more in Google just because of the way those clouds operate. So knowing all three clouds is very important. So we're going to create the VNet. We're going to create a virtual network gateway. We're going to define our local network gateway, and then we're going to connect that using the connection. And then if everything goes well, we would apply a template for our on-premises routers or router, and then we would have a VPN tunnel created, as well as having a BGP peering exchanged. So our first step is building the virtual network, and this is in the Azure tutorial, or sorry, the Azure portal. So we create the virtual network, we define it and give it a name, and we define our region. Now, I'm out of Phoenix, Arizona. As you can tell from my accent, I'm probably not local. So I'm building this out of US West 2. I give it a name, and there's some security stuff here that is automatically applied, and I want to pause this. Oop, see if I can pause that. There will also be uploads of all these GIFs here inside of the, oops, wrong slide. There we go. So this piece right here, it's real quick. There's automatically a CIDR block that is created within Azure, and it's by default, it's 10.0.0/16. It will create one subnet called default, and it will assign a /24 out of that. That's just a default subnet we can apply compute to, so if we want to build server instances, we could pull them out of that portal there. But that subnet is unique to that, but that's only one subnet inside that whole CIDR route. And so you can see showed up. These are all security policies I don't need. Right here, we have that 10.0.0, and we have a default 24 that's applied there. We can add more if we choose. I did not. I just left it as default. Click Next, and then we deploy and apply, and that VNet will be created. The second piece is our virtual network gateway, and this is where it becomes a little bit more difficult. Our first step is we create the virtual network gateway instance, and I'm going to give it a name, tie it to our region, and then change the SKU on that. The AZ2 means I'm going to have an active VPN capability, so I have 2 tunnels that would be created automatically. I'm choosing just the Azure Gateway 2, which is a single instance. It's going to automatically generate a new subnet range inside of my CIDR block because I have that defined in my VNet as part of that 10.0.0/16, but it's going to create a new /24. I have to create a new public IP address that's assigned to that virtual gateway, and then I have enabled BGP, and then I go through and these last steps for each one of them are tags. I did not apply any tags to these, but if we're doing this in production, we probably want to apply tags we can filter. Maybe this is a dev, a prod instance, things like that, billing instances that we can track back. So now we have our deployment process. It's going to create the public gateway, and it's going to create that virtual network gateway. So now we have that instance of the VPN concentrator that is being built inside of the cloud for us. And I want to make sure I didn't miss anything here. Yeah, so I select Gateway 2. Generation 2 is just a SKU. One side note, each of these SKUs here, as the numbers go up, is just the amount of throughput. VPN Gateway 1 is the slowest, but I cannot do BGP peering. I have to go 2 or above, and then 2, 3, 4, and 5 will give me greater throughput through that tunnel. Disable active mode, make sure I enable BGP, give it an ASN, and then I'm off to the races. So I've enabled BGP, I've given it an ASN, we have a public IP address, and we have the peering availability. So our next step is building our local network gateway. Now this is the instantiation of my on-premises router in the cloud. I create the local network gateway, I tie it to a specific resource group that's already been created, which region, in this case I'm giving it a name, just ENCC LGW, and I'm tying it to an IP address. And I blurred out my public IP address there of my router, but I'm just giving it an IP address that will exist. The public IP address of the router, so we can create that VPN tunnel from the public IP address in Azure to the public IP address of my router. Now, the other thing I'm doing here is I'm defining a specific address space. The 192.168.150.0/30, that's my BGP peering address. That says that when I build my VTI tunnel on my system router, use that address space for my local peering, so it knows to accept a connection from that side of my tunnel that I'm writing the routing protocols over the IPSec tunnel. So you can define that, or you can have it auto-pick for you. The second piece of that, the next screen, was defining my my local ASN. I've just done 65,000. One note, by default, Azure will use 65,515 for its BGP peering. Now you can change that. There's some values that it cannot use because it's reserved within their local cloud, but 65,515 is theirs, and you can use whatever you would choose to have internally for your own cloud. They recommend a private ASN, but you can use whatever you'd like there. And I believe that should be it on that piece. Just want to make sure I'm not missing anything or any caveats there. Additional address range is the 150. And again, that can be whatever you'd like. The other part of that is you'll see that address being announced within the BGP table, and we'll do that in the viewing here. Yep, configure BGP. Yeah, so that's just saying, here's my local ASN 65,000, and then my local IP address on that tunnel is the .1 address out of that subnet. Okay, now this is where the rubber meets the road in the connection piece. So we're going to create the connection, and this is where we take the VNet and VGW that we've created earlier, and we tie it to our connection. So we can do either VNet to VNet, we can do an IPSec or an express route. We build the connection there. The next step is choosing our virtual network gateway that we've created and then our local network gateway that we've created. That's going to build those two. We create a pre-shared key. I just use that Cisco 12345 that you saw earlier, but you could choose whatever you'd like there. And here's where we define our security policy. So we say it's an IPv2. We're enabling BGP, and we're doing custom IPSec policies. There's some of the options that you can choose there. And this is where that whole troubleshooting piece comes into play. If I'm trying to, if I'm maybe not familiar with IPSec VPNs, I want to know what phase 1 and phase 2 negotiation problems look like. If I can build an ISAKMP SA, but I can't build the phase 2 pieces with IPSec. What does that look like if I'm not establishing anything at all? What does it look like if BGP is failing? All of these different pieces, and we can select those policies to tweak and change that on the fly, but we can do that very quickly with automation. So we have all of our policies. Our shared key, you can see it's Cisco 12345. And then everything else should be good, and we create it. And this will take some time to deploy once everything is all tied together. But we have the deployment there. So we've done our steps. We've created the VNet, our VGW, our LGW, and our connection. So now we're ready to go. Now in the next step of this, we have to find some information. Remember, we created that public IP address for our Azure VPN endpoint? We don't know what that is unless we go looking for it. So we want to look. We go through the virtual network gateway, and we can find, here's our BGP peer address. It's assigned. That's where my BGP relationship is going to happen with the Azure cloud in my VNet. And the second piece of that is, what is my public IP address of my Azure VPN endpoint? That would be a public IP. I think it's a 4 something this time around, but yeah, 4.154. So that was what was automatically pulled out of their pool and assigned to my VPN endpoint. So when I build my tunnel, that's where I'm pointing to. So we found that information out with the cloud. And finally, I'll apply our template to our, in this case, I'm using a Cat 8000V, just locally in my vSphere environment. And I'm going to see 2 things that pop up. Once the tunnel's established, I'll start seeing traffic spike. And that's in that virtual gateway status page. So I see the traffic coming up. That means I'm exchanging something. In this case, it's probably our BGP announcements. It's a low volume of traffic, a few thousand bytes. But if we go into BGP peers under the virtual gateway, we can start seeing that I'm learning some routes. In this case, the 192.168.128 network, that's my local home network. So I'm learning that 24 via BGP, AS 65,000, as well as the 150, which is that local tunnel endpoint that I've also assigned. So I'm learning the BGP peer, so I have full visibility, as well as here's basically the show IP BGP summary up top there. So I can see the peering, and I can see the routes that I've received all through the cloud. I didn't show the output from my Cisco router because we've all probably configured BGP or some kind of routing protocol with the show IP route, so I'm not going to bore you into that. So where's the troubleshooting piece of this? All I've done so far is blather on about how you create this in the cloud. Well, our first step, and what you should probably do by going through the whole ClickOps process, is learning how things are created. Every cloud is different, and that's why I created 3 separate tutorials, 1 for each cloud. You want to make sure that following those tutorials or your own process, you're going to be able to create the IPSec tunnel as well as the BGP relationship. Or whatever, if you're doing static routing or something like that, making sure we have some traffic passing back and forth. But the troubleshooting piece of it is, okay, I've made this work, how can I break it? And like I said, that was only 5 steps, though I did it over a holiday, and it probably took me about 45 minutes sitting in front of my PC to click through each of those things, wait for it to build, make sure I had the output, move on to the next step. Because you saw each of those things was chained. I could create the VPN gateway, I could create my local gateway, but I couldn't create my connection until those 2 pieces were already instantiated. So I had to wait for those dependencies to be fulfilled. So it takes a long time, and I have to sit in front of my computer. I like to go and get coffee or something like that. I don't want to have to click it 1,000 times. So we need to find ways that we can break the configuration from both the router side, which we can do pretty easily, or the cloud provider. That sounds like a problem for automation because we can treat our configuration and our resources like cattle. We can build them up, test them, destroy them, and try it all over again. So what declarative cloud-centric infrastructure as code tool could we use to accomplish this? If you could use PowerShell for Azure only. You can use things like Pulumi, assuming you know how to write the code to support the Pulumi providers. Myself, I'm kind of a Terraform guy, and Terraform was meant to manage the clouds, so that's what I use. So I'm going to jump into a quick showcase of the code that you will all be receiving as part of this at the end of this session by going to my GitHub, and but I want to walk through that with you all before I jump into it. So this is Terraform. For those of you who have not seen Terraform, there are several Terraform sessions that will be occurring in the DevNet workshop. There's also an intro to OpenTofu, which is kind of a Terraform fork that will be done in the Cisco U Theater, I believe, tomorrow. Additionally, there are resources in Cisco U that I've created around how to use like an introductory to Terraform. So you can get started building your own Terraform configurations that way, again, by creating a free Cisco U account and accessing those tutorials. And if you're interested in learning more about Cisco U, just behind the wall here, there's a demo we can give you to show all the things that are available, both free and paid tier if you choose to go that route. So I've defined my required provider. In this case, I'm just talking to Azure. We have to make sure that I have the credentials there, so I'm using a subscription and tenant ID that's tied to my username. And each of these things should look very familiar to what we created earlier. Now, I hoped before this presentation to have time to use a tool called Terraformer, which allows you to extract configuration that you build in the cloud, and it will build the Terraform plan for you automatically. I didn't have time, but if you follow that GitHub with a little star, my repo with a star, I'm going to update that with at some point, and I'll also update it with all the cloud providers, so Azure, GCP, and AWS as well for all that automation. So follow that along. I can't promise it immediately. So our first step there is we've created that VNet, and we can see that we have this Azure RM virtual network. And there is our address space, that 10.0.0.16 that we created before. We have a subnet here, and by default, when I create something with Terraform, it's not going to build the subnets for me, like it did with the ClickOps. So that ClickOps automatically added that default subnet for me. It's not going to do that if I use Terraform. So I create two subnets, 10.0.0.0/24 and 10.0.1.0/24. The important piece here, and what I did not highlight earlier because you couldn't really see it, is that to use a subnet as a gateway subnet, it must be called gateway subnet in Azure. If you call it anything else, it will say, I can't find gateway subnet for my virtual network gateway. I'm going to fail. So you have to call something gateway subnet if you want to use that for your virtual network gateway. So I've created these two subnets. I then create my local network gateway, so that local gateway that we defined earlier. And this should also look familiar because I'm calling out my BGP ASN and where Azure should be looking for that BGP peering address, that 192.168.150.1. It's going to create a public IP address for me, and it's just going to allocate that dynamically. I don't have a pool of addresses within Azure. Just pull it out of the pool that it's available and give one to me. And now I build, let's see, this is my virtual network gateway here. I'm sorry, this is my connection. Nope, that's my virtual network gateway. So yeah, okay. So my virtual network gateway here, we are calling it type VPN. There's that SKU, that VPN gateway 2. The BGP ASN of that peering is also defined there. And then use the public IP address that you assigned earlier. So it builds the public IP address, but make sure you pull that into my virtual network gateway so I have that linkage there. And then finally, let's build our connection. So it's type IPSec here, and that's important because we can, like I said earlier, we can build that VNet to VNet. So you've got two VNets. You can build a VPN that way. You can build an IPSec VPN, or you can build a connection over ExpressRoute, which is that hosted. You can get through in the States. You can get it through like Megapath and others like that. I'm sure there's something similar here in APJC. We're going to use a pre-shared key, and here is that IPSec policy. So phase 1 and phase 2 for IKE and IPSec, we can change these values very quickly. So if I wanted to use something like SHA or MD5, some more insecure protocols in my integrity pieces, if I wanted to change my Diffie-Hellman parameters, if I wanted to change my PFS, we can change those right here. So we can build different VPN tunnels with different security characteristics, apply a template that doesn't match, and see how phase 1 looks and how phase 2 looks, so we can be comfortable with that troubleshooting process. And the best part of this is, okay, and then also I have these output parameters where I'm going to spit out my ASN of my peer, my BGP peer IP, and my tunnel public IP address, so I can pull that out of the Terraform automatically, so I don't have to go searching for it. It's going to spit it out for me. Now, if everything worked, and timing is correct, we have the tunnel that's built. So all of that's done. It's taken, I mean, you can see the time here, even with Terraform doing all of its what audio testing. We still good? Okay. We can see that it's taken about 25 minutes for me to build that VPN connection. So it's still going to take a while, but I was doing a lot of other things while that was building, and I didn't have to sit down and babysit it. So I have all of that information out. We can see that we've got the 65.515, that 10.1.254. By default, that BGP peering will occur over the last IP address, or last usable IP address, or last free usable IP address of your gateway subnet. That's just how Azure does it. And then my tunnel public IP, in this case, that 4.155, 134, 138. So all of that is done, and I can apply. This is where I've got to be fast with my fingers here. I also have a template that I will show that will be uploaded, and this is based on what I've created inside of Terraform with the security parameters and the BGP pairings and all that stuff. I have created a template that I will also upload into my GitHub, where all you have to do is copy and paste the appropriate parameters. In this case, just public IP addresses on mine, but you may have to do a little bit more. Let's see here, make sure that keyring is changed. And tunnel destination gets changed. IP route, all of that should look good. Okay, yep, we're good to go. So I've edited this template with that BGP, I'm sorry, the public IP address information that I got from Terraform. And if I copy and paste this, I have a connection to a router that's sitting in my house. And for those old enough to remember Rocky and Bullwinkle, the nothing up the sleeve aspect, I'm just going to show run. There is nothing here that is pre-configured. So we have no, aside from IP addresses and some default routes, there's nothing that sits on this router. So if I copy and paste everything, and because it's going halfway around the world, it may take a second. That configuration will be pasted, and at the end of it, we will start seeing the IP address, we will see the phase 1 and phase 2, as well as our BGP relationships that we've established on our router. And hopefully it happens fast. Show crypto IKE v2 SA det. We have our, I'm almost done. I got 3 minutes. I'm checking. I got my clock right here. We see we have phase 1 up. If we do a show crypto IPSec SA detail, we have our phase 2 should also be up. And finally, if we do a show IP BGP sum, we have our peer with Azure. So again, all of that was under ideal conditions. We have phase 1 and phase 2 negotiation parameters that match what's in my template, but we could do a Terraform destroy, and I'll kick that off right now, just so you can see what it looks like. If we do a Terraform destroy, all it takes is that command. I'm going to destroy the cloud configuration. I can change whatever parameters in my TF file, and Bob's your uncle. You're back in business. So with that, I'll wrap up very quickly. there's the QR. There's the QR code. You take a picture of that. That will link to my GitHub where I will upload the PDF, the configuration template, and the all the other stuff. There'll be some Terraform, README, cross-links, and other software is appropriate. I'll leave that up. Please fill out your session surveys. If you like the session, I can do more of them because they'll bring me back. Cisco U on the backside for the for more explanation. ENCC QR codes up front there. And for those of you who sat through, listen to me blather on for 30 minutes about Cloud VPN, I'm going to draw one lucky number, must be present to win, for an Echo spot. Ticket number ending in 2469. 2469. Oh, don't even have to go very far. Yep. All right. Echo spot for you, sir. All right, and if you have any questions, I will be around the Learning Certifications booth all week to talk ENCC. Patrick Gargano, who helped create the tracking, will be here. For those who are interested in learning more about the back end, the cloud side, Kareem will be following up next, talking more about the guts and specifics of AWS and all